Hello and welcome to our strategy outlook on 5G Core, part of our Spotlight on 5G series. I'm Guy Daniels, Director of Content at Telecom TV. Now, the specifications for a new cellular core to replace the existing EPC of LTE networks was introduced by 3GPP in Release 15. Whilst the earliest implementations of 5G NR in the radio access network still use the LTE core, the so-called standalone mode of 5G utilises a brand new core network. As we're about to discover, this 5G core will deliver the full promise of 5G systems, enabling the creation and delivery of a new generation of services. Now, coming up later in the programme, we have a roundtable discussion featuring executives from Orange, BT, HPE and Intel. Plus, we talk to a number of telecoms leaders to get their views on 5G Core. But first, we have an exclusive interview with George Nazi, Global VP for Telecom, Media, Entertainment and Gaming Industry Solutions at Google Cloud. My colleague Rayla Matra spoke with George earlier and asked him why the 5G standalone core deployments are so important for telco service strategy.
5G standalone is extremely important for the communication service providers that want to unleash the totality of the power of 5G. If you are just entering into the 5G domain, you can probably still get away without having to have a 5G standalone core. But if you really want to unleash the totality of the power, and what do I mean by that? 5G has multiple capabilities that it will bring. It will bring, of course, a throughput, which is 10x what we've seen at 4G, but it's also will provide an acceleration in the mobility capability, tracking mobile devices at 500 kilometers per hour. It will have a latency capability at less than 10 milliseconds as compared to probably 40 to 50 milliseconds with 4G. It will provide the capability to have millions and billions of devices, way more than 4G provides. So there are multiple capabilities that 5G brings that 4G has not been able to bring. Two, with 5G, the architecture is much more in tune with a cloud native architecture where you're leveraging the scale of cloud in order to provide that capability. Three, with 5G, you'll be able to create an end-to-end slicing capability service. You'll be able to leverage the capability of the data, the machine learning, the analytics. You'll be able to leverage the architecture capability of a cloud when it comes to DevOps, when it comes to continuous integration, continuous development. So there are many things that 5G brings, and if you tie it to the traditional core, I'm not going to say legacy core, but to the traditional core, you will not be able to unleash the total capability of 5G, which is why it is important, and many telcos are focusing on the 5G core assay. And you see many operators discussing and talking about this, especially as we move into some of the open RAN capability as well, and how do you disaggregate that capability.
So what role do cloud platforms play in 5G core deployments? And can we expect to see hybrid cloud strategies dominate?
Clouds play an important role in 5G, especially when it comes to deploying 5G on a native infrastructure. So if you really want to enable the scalability of 5G with the latency that's needed, you really would need to be able to implement a native 5G cloud capability so that you can have this underlying the infrastructure, especially as you move into continuous integration, continuous development, leveraging a lot of the scalability of the cloud, the security of the cloud, and definitely the hybrid cloud implementation is extremely important for us. For instance, for us at Google Cloud, we deliberately are building Anthos in order to operate in a multi-cloud, hybrid cloud environment so that to enable the CSPs the flexibility, no vendor lock-in, at the same time allow them to have the power and the scale of the cloud. So definitely hybrid cloud will play an extremely important role, similarly with multi-cloud, and the cloud native infrastructure will allow you to have a much reduced cost implementation of 5G at a much more scalable and secure option.
Is enough attention being paid to the next-gen OSS and BSS requirements of 5G? Is the development and deployment of such support systems important?
Definitely extremely important. It's extremely important, and we probably are not paying enough attention yet on the OSS and the BSS. And that's because most operators and most of the technology has really been looking at how do you implement the components of 5G. How do you implement the core, as we just discussed earlier, the virtualization capability when it comes to the RAN and other areas? How do you embed the native cloud, the Kubernetes, the control plane? How do you implement not just virtualization, but the software-defined network aspect of it? Moreover, there are the services that will be enabled on 5G that will make it fairly complex for the OSS and the BSS to deal with, especially when we talk about network slicing and delivering that to the enterprises, or when we start talking about VR or virtual reality or XR. And finally, how do you also harness the data analytics and AI? So what we are seeing is that as you start moving into 5G and start implementing this capability, the orchestration layer becomes a very important component on the OSS and BSS. And if I want to draw on my previous experience, when we looked at OSS, for instance, usually you divide it into 6 different platforms, assign, design, logical inventory, fulfillment, assurance, security, network planning, and workflow. A lot of these elements will also start becoming part of the implementation that you do on 5G as part of the orchestration. 2, you have to be able to manage the new and the old as you start building that OSS around that capability. And 3, you really need to think about the new services that you will be launching, and then how do you provision these new services that I touched on earlier when it comes to the OSS and the BSS, and how do you bill for it and how do you monetize it? So not enough attention is yet being paid. Everybody is thinking about this. The ecosystem partners are all looking at this because right now we've been focused much more on the network aspects of 5G and the containerization of that capability.
Excellent points there, George. Now, you mentioned security in there. And as 5G telco platforms become more open and distributed, what does this mean for the security considerations of network operators?
Security is an extremely important element, especially in a distributed model. As cloud players, we have embedded security early on in our distributed capability as we developed our cloud solutions. As you know, Ray, at Google, for instance, we have 9 different products that has more than 1 billion users on each of these products, between Gmail, YouTube, and other products. So what's important here is how do you embed security in a distributed model? At the same time, there is an advantage when you embed it in a distributed model because you can actually isolate if there is a security breach, isolated into just that distributed model where the attack happens. Of course, there will be more sophistication, but there's also much more security. We've had to really embed it and develop our security aspects at scale in order to fulfill the demand of our clients and the billions of users that are implemented in order to also reliably provide that service. And the same thing for the CSPs. They will really have to think, and this is a big area that we're helping CSPs in how do they develop the security aspects in a distributed model versus a centralized model.
And that brings us neatly on to how Google Cloud is working with telcos to advance their 5G strategies. Is Google Cloud a natural partner, and do you encounter much skepticism about the role of public cloud companies in 5G?
We believe we're absolutely a fantastic partner for the CSPs. And actually, our strategy is deliberate to partner with the CSPs and the ecosystem partner. One of the, probably 4 or 5 things that we differentiate ourselves and that we're partnering and we're leveraging with the CSPs is the fact that we have at the core of our cloud a very large scale network that's highly secure, highly reliable. So we take that capability and we complement it with the CSPs in order to unleash the power of the CSPs when it comes to the edge and the new services. Two, at the heart of what we do is an open source heritage and legacy, where that enables the CSPs avoiding vendor lock-in and also an acceleration from a development perspective in order to be able to run on Google Cloud. 3, we're enabling Anthos, which is a hybrid cloud that allows as well the CSPs to be able to go uniformly from the IT estate to the network estate across multiple clouds. So the partnership with the CSPs is extremely important and crucial, especially, as I said earlier, that we see with 5G a massive growth of devices that requires the collective partnership between the cloud players, the communication players, the ecosystem partners, in order to really enable and unleash that power to give the benefit to the users, whether you are a consumer or an enterprise user. So we have many engagements and conversations with the clients. We understand the complementary effect and the deliberate strategy where we don't compete with our partners, with our CSPs, rather than we partner with the CSPs in order to unleash that capability.
George, are you still encountering much skepticism about the role of public cloud companies in 5G?
Not as much, because once we have engaged with the CSPs and we are having the conversation about how do we unleash the collective power of 5G, together, how do we unleash the power and the scale of 5G across all of these services, we are discovering that actually it takes a village to really provide that capability. It takes all of us, along with an open ecosystem of partners, to really be able to deliver that capability. 2, none of us alone will be able to provide this. Even though, for instance, Google has a significant network capability at the core of it, there is no way we can go into 200 plus countries and be able to provide that capability in each and every country, which is why the partnership is extremely important with the CSPs, and the CSPs are understanding this. And actually, the advantage is how do we leverage the power of the cloud to enable these services and capabilities to unleash the 5G services, whether it's the consumer or the enterprise, via the CSPs. And together, we're able to do this.
And how important is sustainability to the communication service sector right now? And will the shift to 5G help the industry to meet its sustainability goals?
Sustainability is extremely important for us, for the world. And the collective have been working significantly on this topic. We have seen that in 2010, enterprises have used 1% of the electricity, while in 2020 they doubled the amount of electricity being used. Sorry, not doubled, 10x the electricity that's been used, while the power that was consumed was only 6%. What that means is everybody is putting their effort into this. 2, as we said, with 5G, there is an energy efficiency that will come with it, but at the same time, because there are billions of devices, that means we're going to be using way more electricity, which brings the sustainability agenda at the center stage. And as Google Cloud, we pride ourselves to be the cloud player with the most green electricity that's being used. If I want to give you some stats, Ray, if you don't mind, I'm just going to give those to you. In 2007, we were the first major company to become carbon neutral. Since 2017, every year we've matched 100% of our electricity consumption with renewable energy purchases. 2021, we're the first cloud to launch carbon-free energy scores. And today, Google is one of the world's largest corporate purchasers of clean energy. And by 2030, we aim to be the first major company to operate carbon-free 24/7. Sorry, I had to read them. I just wanted to give you the accurate statistics about how important sustainability and green energy is for Google Cloud and for Google, and how we're really putting this at the center stage of our agenda.
That was George Nazi speaking earlier with my colleague Rayla Matra. Good to hear not only about the need for partnerships, but also of the scalability requirements of 5G and the need for a cloud-native approach to core infrastructure. Well, we've been speaking to a number of other operators and vendors for our Spotlight on 5G series, and we're going to hear from some of them now. We spoke with Chandresh Ruparel, Director of the 5G Wireless Core Infrastructure segment at Intel, and began by asking him about the challenges faced by CSPs as they transition from 4G to 5G standalone cores.
So this particular inflection point for the comms industry is especially challenging because there are multiple transitions happening at the same time. You see cloud ready to cloud native transition. You see we are going from a single vendor proprietary core to a multi-vendor 5G service-based architecture, going from a single cloud to multi-cloud environment, from a highly centralized core to a core with distributed edge. And again, the higher level of distribution makes it, again, very challenging. And in the midst of all these transitions, carriers are looking at how do we get cycle over cycle improvements, and significant ones, in total cost of ownership. How do we drive ease of deployment, interoperability, automation, and agility in the network?
Chandresh explained that to just deliver technology solutions to the platform is not enough, with 5G processes needing to be highly replicated and scalable, meeting stringent workload performance levels.
So Intel works on real-world workloads and ecosystem partners, and with ecosystem partners, to ensure that we are developing optimizations and best practices that apply to ultimately what's going to be commercially available to the carriers. And these optimizations are with due consideration to real deployment environment of the carriers, which means taking into account the throughput requirements on a per location basis, the space constraints, the features that are necessary to deliver the solution, the rack level architecture, and multiple other considerations that make this really effective in understanding how it benefits the KPIs and the total cost of ownership for the carriers. Our investment in cloud native, which is a very important aspect of this multidimensional transition for the carriers, is also a multidimensional investment from Intel's side.
Another company with a long history in telecoms is Hewlett-Packard Enterprise. But with 5G, the vendor has decided to take a fresh approach to the market. Here's Richard Band, Head of Mobile Core and 5G in the Communications Technology Group at HPE.
When we looked at 5G and we looked at the container approach and the cloud native principles, we said, you know what, this is time to do a clean sheet. This is time to make a radical step to make telecommunications less special and adopt more IT tools and technologies. And this is exactly what we've done. So we've implemented an open cloud native approach where we try to leverage as much as possible existing technologies, especially from the open source community. And we're working very closely with our partner Red Hat to leverage the OpenShift capabilities. There's a clear need for more integration, and we've decided to step up to that challenge, and we launched last year our 5G core stack. So our 5G core stack is really aimed at providing end-to-end integration top to bottom, so from the infrastructure all the way up to the application, but also across the different network functions, working with partners that have a similar approach to us in terms of adoption of cloud native, to provide a pre-integrated end-to-end 5G core. In that way, we aim to reduce the risk of our customers at the technical level, and at the same time, at the commercial level, we're introducing what we call the consumption-based pricing to also mitigate the commercial risk of the introduction of 5G. So in a nutshell, this is how we approach the solution for 5G. So a different cloud-native architecture, a end-to-end integration to reduce technical risk, and a consumption-based pricing to reduce commercial risk.
A reminder again about the importance of adopting a cloud-native basis for 5G. Also interesting to hear how HPE took a clean sheet approach to 5G core. And the introduction of consumption-based pricing is well worth a closer look.
Allowing, using consumption allows them to scale up the capacity they need and pay for the capacity they need only when the demand is materializing. And in phase of an uncertain demand, I think this is creating value for our customers. There's a second reason, which is linked again to the monetization of 5G. I do believe that 5G is going to be monetized primarily through enterprise. And typically, when we discuss with the enterprise side of operators, they tend to have a desire to have a much stronger alignment between cost and revenue than we know historically in the mass market. In the mass market, we're quite comfortable as an industry to invest into a network and then see how we monetize and how customers are coming. On the enterprise, I see a much stronger desire to align specifically the cost and the revenue. And again, consumption allows to do that. You pay on a monthly basis per subscriber, per slice type, and that is very closely related, of course, to the revenue that an operator makes with the enterprise customers.
That was Richard Band, and we'll be seeing him again shortly for our roundtable. Now, security is a major concern with 5G. However, 5G is advertised as the most secure 3GPP generation yet, with many of the historic security issues now resolved. So we asked Tom Walker, Manager for Consulting Systems Engineering, Telco and 5G at security specialists Fortinet, if he agreed with that assessment.
I think when we look at some of the historic problems that have been within the different 3GPP generations, 5G makes huge strides forwards in mitigating those historic issues of security, privacy, and other functions. So certainly, I would in part agree with that. However, one key aspect is that although 5G brings enhancements with resolving those historic security issues, the shift in the technology, the architecture that's used, and the overall way that 5G is built and deployed by embracing new services like web services, cloud platform, software-defined networking, network function virtualization, they ultimately also introduce additional levels of risk and threat that the operators need to consider. So those particular issues were not so present with the older generations, and the traditional issues with those older generations have somewhat been resolved, but there are other areas of security focus that the telcos need to think about. For example, 5G brings a lot more service exposure. So being able to expose more of the functionality, more of the service capabilities to the customers and to third parties, as well as to other operators. And also, for example, programmability. The 5G network and the cloud platforms in which they run are driven by a programmable nature. And that programmable nature also brings with it risk and threat.
We then asked Tom about the specific security implications for 5G core, with 5G being a more natively open and distributed system.
So I think we need to think about fundamentally that this more open and distributed architecture powers the new services and functions that 5G offers and potentially offers. But in order to do that, there needs to be more integration with additional third parties and vendors and technologies, and embracing more open and connected methods of that integration. And that naturally brings a level of risk and threat because, yes, something is more open, but at the same time, being more open means that you potentially expose yourself more to risk and threat. The other aspect that's important here is that the network architecture and the services and how they are delivered requires more of that function to be distributed closer to the consumer, closer to the edge, ultimately closer to the subscriber. And that means distributing functions that are traditionally within the core of the network, much closer to the edge of the network. And those functions are critically important in delivering the overall capabilities, but also importantly, they are a potential threat vector back into the rest of the network environment. And also by distributing that environment capability, you as an operator naturally have to embrace locations that are not necessarily within your control. And that could be at a customer environment, a customer site. It could be a third-party environment or site, or it might be a third-party cloud platform provider or cloud service provider. And that brings with it an additional level of potential threat and risk as well.
Tom Walker of Fortinet there, articulating the challenges around 5G core security. And you can watch full-length versions of all these interviews. They are all available to view on demand. And you'll find details on the Spotlight on 5G section of the Telecom TV website. Okay, it's time now for our roundtable discussion on 5G core. So let me introduce our panelists. Emmanuel Bidet, who is VP Convergent Networks Control at Orange. Mark Henry, Technology and Business Strategy Director with BT. Alex Quash, who's VP Data Platforms Group and GM Wireline and Core Network Division at Intel. And Richard Band, Head of Mobile Core and 5G Communications Technology Group with Hewlett Packard Enterprise. Hello everyone, very good to see you all again. Now, I'd like to start off our discussion by asking about the practical implications for running 5G core alongside a 4G EPC and how this might impact operational processes. Alex, would you like to have a first pass at this question for us?
Sure. We see two primary deployment models within this transition. The first one is around independent islands of deployment, independent island of 4G EPC, and then the 5G standalone core. And in this model, service providers can add capacity and expand independently with the EPC or the virtual EPC, and then the 5G standalone core. The second deployment model is really around cap and grow deployment model, where service providers are capping their 4G EPC infrastructure and growing the 5G core. And this is done via a dual mode implementation. And they add capacity via this dual mode implementation around expanding the infrastructure capabilities. Practically, from a customer experience perspective, from a back-end perspective, service providers really are looking to drive consistency in billing, in authentication, in policy management. And this is really, while the cores are going to be different from 4G to 5G, it's no different in transitions from 3G to 4G and now 4G to 5G from a service provider perspective, as they have a lot of experience managing through transitions, and they do generally a great job with this type of consistency. And then the last piece is around devices and devices that support dual mode, non-standalone or NSA and SA standalone implementations, where service providers can actually direct voice or data traffic following their policies, following their implementations. And really, those are some of the considerations, the practical considerations that you were asking about.
Thanks, Alex. And Emmanuel, do you see any specific new practical implications for running 5G core alongside the EPC, or is this very much a similar process to what we've seen before in our transitions of cellular?
In fact, yes, we are used to introduce new technology. 2G, 3G, 4G, 5G in SA, now 5G SA, and it's our history. But you're right, there are some points that are maybe different in that new technology, and we have to be cautious in their management. The first one is that we have there a fully virtualized, fully containerized solution, and that is quite new for us. The second point is that we want to change our process in order to automate much more than before, and this is also a big challenge. And the third one is that this new technology will offer also new features: high bit rate, low latency, control plane, user plane separation, analytics, network exposure. And of course, the new features will probably imply also new architecture, new processes, and this is clearly also a challenge.
Great, thanks for that. And I'd like to ask Mark as well. Is BT taking a similar approach, or are you looking at things differently?
Yeah, I mean, I recognize a lot of that change in processes, particularly when you're moving to a kind of cloud native architecture. You need to introduce agile ways of working. It's a complete change for the way our people work. If you look at 4G introduction or even 3G introduction, you have the usual challenges of a generational change where your key teams for design, build, and operate are the same people that you want to operate your existing platform. So you have a pinch point. But really what we're doing now, and in our case, we're starting by swapping out our EPC and doing that with 5G SA build in mind and going to a cloud native architecture. So introducing virtualization and the containerization and the virtualized network functions of VNFs. And that introduces a whole new set of challenges on their own, even before you start to build SA on top of that. So what we're doing, the approach that we're taking is we're replacing our EPC. We're getting as much learning as we can from that and then accelerating into standalone. But practically speaking, there's a lot of challenges with that in changes of ways of working.
Thanks, Mark. And are there any specific pain points for an operator as they actually make that move to 5G core?
Yeah, I mean, the challenge is going to be a lot in the customer process. So it's a SIM swap for all of our customers. It's a change where we'll introduce a whole new set of functionality that we really need to embed into our organization. And the key pain point, I think, is across this move to a cloud native architecture is the amount of integration an operator is going to have to take on. So we become the SI. We have to do the integration from hardware, hypervisor, orchestrators, and all the different VNFs. And that's not something that we have a great deal of experience of as operators, as an industry. But we're learning very, very fast. And I think that 5G SA is definitely the moment to grasp that nettle and move forward.
Thank you, Mark. And Emmanuel, we talked about running a 5G core alongside the EPC, but are there specific pain points when you transition to using 5G core?
I think, as it has been already said, the most challenging for us will be to integrate the whole solution. I mean, vertically, VNF on the infrastructure, but also horizontally from an end-to-end point of view, including devices on radio access. This is quite new for us. I mean, the whole thing, integration horizontally, vertically, and of course with all the IT system. And it is maybe more challenging because what we want to do is something almost fully automated at the end, and this, of course, will imply a lot of changes again in our processes, in our skills. But as it was said before, also we have been moving on that path for quite a long time now.
Indeed, thank you very much for that. And let's find out what our vendors are seeing as well. Richard, from your discussions with operator customers, what are you seeing as some of these pain points?
Both Mark and Emmanuel mentioned the integration challenge, and it's clear that the direction of travel here is disaggregation of the network, separating in smaller blocks, separating them in individual layers on the infrastructure, virtualization, containerization, and then the application layer on top. And then if you look at the network itself, we have many more network functions now than we had before, being decomposed into microservices. So disaggregation of the network is a reality, and that then means there's a need to do integration very clearly. While larger operators like Orange or BT may have skills in-house to do such an integration, it's very clear that a lot of the operators are, especially the smaller ones, are struggling with this challenge and are clearly looking for help to do this integration. I think this is clearly where we as vendors need to step up and can step up and help them mitigate the risk of the integration, help them accelerate the time to market, and make sure that they get something, as Emmanuel was saying, that is automated from day one, which is precisely what we are aiming at with the HP 5G core stack.
Thanks. And Alex, as Richard said, there's a lot more elements involved in this transition, isn't there? So can you explain to us a little bit more some of the pain points that you're seeing and witnessing?
Yeah, I think Richard, Mark, and Emmanuel have actually articulated some really compelling issues that they're seeing relative to the transition to cloud native. And along the lines of what Richard was saying, as vendors, we're also looking at other pain points, such as as service providers move to a virtualized environment. There's actually more and more servers coming into play, and power becomes a bit of an issue. In addition to that, performance just doesn't rest, right? As we transition from 4G to 5G, service providers are still looking to get the absolute best performance out of their virtualized solutions as they deploy. And so Intel, working along with HP and HP 5G core, we continue and strive to deliver the absolute best performance on these virtualized platforms with the lowest possible power configurations in working with validating new ISV or software vendors that are coming onto the network so that they have service providers can actually have the best solutions accelerated from a time to market perspective from the supply chain.
And Richard, you spoke about how integration could be a pain point for CSPs in this process. With so many components to the 5G core, what is the ideal integration strategy for operators?
Well, I don't know if I can say that there's the ideal integration strategy. First of all, I think it depends on the role that the operator wants to play. So we certainly see some customers that have, as I said before, strong in-house skills. They have the ability to go out and select for themselves the right infrastructure layer, the platform as a service, and flexibility and capability to bring together a relatively large number of suppliers, say up to 10 suppliers for the different network functions. It's a good strategy for those who have those capabilities and the time to do it, but it's definitely not for everyone. What I would say is, generally speaking, what I see is a more limited set of suppliers. Quite frankly, also from our side, when we build our core stack, we are working with 2-3 maximum suppliers to put everything together. And this is, I would say, not so much because of the functional integration. So, as per pure 3GPP compliance, this is relatively okay. This is quite straightforward. But the real prize in all of this and the real challenge at the same time is the integration at the non-functional level. A disaggregated cloud-native solution implies that a lot of the non-functional components, the logging, the tracing, the security, the caching mechanism, there's a lot of elements there that are taken from standard IT tools and technologies that can be leveraged across network functions from different vendors. But obviously, it requires you to work together with the network vendors and look for compatibility in the approach and making sure that everybody is taking the same approach towards cloud native and then integrating all of these elements together to have, for instance, end-to-end tracing across all the network functions done seamlessly, to have one single CI/CD chain so that you can implement change fast and roll them out in an automated fashion. So this is where I think the focus needs to be. The equation, the outcome of the equation is probably slightly different for every operator. And again, the first question to ask for an operator is how much do you want to do yourself and how much do you want to rely on your supplier to do this on your behalf?
Yeah, thanks, Richard. Emmanuel, when you just look at the 3GPP specifications alone, there's over like 20 different components that are specified. We're talking a large number of components here. So what is your recommendation? What are you deciding to do yourselves at Orange, or what are you seeing elsewhere in terms of integrating all these components for the 5G core?
Well, you're right. We have many VNF, and the potential could be huge. What we have decided is to let's say to limit the problem as much as possible. So that's why we have decided to have 3 vendors at maximum in our first deployment in Europe. Basically, one for the core, one for the database part, and one for the signaling part. I think it's a good way to take the problem, because we will not have so many let's say so many vendors to align. We have 3 very current domains. On our side, we think it's a good trade-off between complexity by having too many vendors and let's say too much or too long simplification with only one vendor, which can imply also other problems like vendor locking on the long term.
Thank you, Emmanuel. And Mark, it's a difficult equation, this, isn't it? On the one hand, you've got far greater choice with 5G Core, a lot more vendors, a lot more areas for them to come in and collaborate with you. But on the other hand, that in itself leads to added complications.
Yeah, actually, I completely agree with Emmanuel, and our approach is very similar in that we have one vendor for the main core components, one for the subscriber database, and another for the signaling network. However, we are actually have a whole load of other vendors. We have the hardware layer, the operating system, and the management and tool chains to get us there. And in our case, the core is both a 4G and a 5G core when we get to SA. That's a simplification that actually I think is really important, because we'll get some commonality and that will simplify migrations over time. But the other thing that I think will be interesting in the control plane, user plane separation, that we might start to see multi-vendor there. And I think that's an opportunity to explore, but it's not something we're doing right now.
Yeah, good point, Mark. Thanks for that. Emmanuel, if I can come back to you. We spoke about the interoperability challenges. We spoke about the multi-vendor 5G core. How can a cloud-native approach help when you're looking to swap out suppliers, say, without disrupting your ongoing operations?
Well, in our case, what we have decided is to deploy the 5G SA using, let's say, the overall mode that has described Alex at the very beginning. It means that we will set up a new networks. New 5G SA customers will be managed by this network whether they are on the 5G coverture or 4G coverture. That's why we think it is more simple, because we avoid any, let's say, any changes for the existing customers. We avoid any interference between what we will do on 5G SA and what is existing in our other networks. It will allow us to have the time needed to fine-tune this new network. Once it will be done, it will be easier after that to migrate the different services that we have, 5G NSA and 4G on this new network. So the way we have chosen is to separate, let's say, the problems and to start with real new networks where we will offer our new services.
Thanks, Emmanuel. And Richard, you'd like to comment?
Yeah, I think your question was around how can cloud-native technologies help to make changes in the vendor landscape, right? To swap one supplier of a network function for another one. And what Emmanuel described, I think, is working well for the initial deployment. But we have to recognize that 5G is still very much in movement. I think both from the standards perspective, there's still a lot of things coming our way. We've released 17, but also from a business perspective, the monetization of 5G is still very, very early stage, and the majority of what's being done today is still very focused on enhanced mobile broadband. We all believe that other things will come when we get closer into the specifics of the enterprise use cases. So the question then becomes, the suppliers that you select today, are they the right ones for the capabilities you need 2 or 3 years down the line? And if not, what can you do about it? Can you change? And fortunately, I think Cloud Native can really help here. Clearly, one of the objectives of Cloud Native is to enable us to make smaller changes, more frequent changes, but more importantly, to make changes very continuously. Instead of having these big changes in the middle of the night, to be able to roll out change on a continuous manner. And there are several mechanisms that allow us to do that. There's mechanisms, I would say, that we inherit from the IT side. So people talk about rolling upgrades, canary upgrades. So the ability to deploy a new version of a piece of software and then have existing sessions terminate on the old software and new sessions starting on the new software. Typically, in the past, we had to use routing inside the network. Now we can do this at the application level in the Kubernetes environment. So this is one thing that can help us be more flexible in making changes. And I think the other one is, which is something that is not mature yet today, but will be, and is one of the big promises of 5G, is the network slicing. So obviously, the moment we have multiple slices, we may even envision creating new slices with a different set of vendors, test them, and then through simple configuration changes, move customers from the old to the new, and in that way, get much more flexibility in changing suppliers. So those are some of the things I see, still early stages, but I definitely believe they're going to make our life simpler and are going to help create the flexibility that operators need.
Thanks, Richard. Well, I think that's a good time for us to perhaps move on to look at services and solutions. Mark, what new capabilities does a telco operator need to develop new services, new solutions, and how can 5G Core specifically help them with this?
Yeah, I think I'll pick up on Richard's point actually about slicing. For new services, slicing presents an opportunity that we haven't had before. So for new services, partners are really important. But with partners, you need to do some co-creation to build a service. You need to trial it. Typically, that's been really difficult in very fixed infrastructure to build a network for a trial and then scale it up. Cloud native changes that. So I think there's an opportunity for, firstly, to start off with an innovation slice. So you build a slice, and again, you can introduce a new vendor for some components of that. And then you partner on these new services within this slice, and you can have that use your live network. So you can start trialing, co-create some new services with a partner, with their partner applications that you're onboarding, and then start to scale it and build new services that way and fail fast. And these are all the things that we kind of get with a cloud native architecture that we've not had before. And I think that the opportunity that we describe in enterprises and new services will be enabled by that kind of route to market.
Thanks, Mark. Richard, Mark just brought up that great point there about co-creation, the need for co-creation as we start moving forward with new services. Is this something that you're also seeing?
Yeah. I think what he said resonated very much with me, both the co-creation and the fail fast element. And I think this is the fundamental difference in 5G compared to previous generations of networks, is once we have the network in place, the service is not then done yet. In previous generations, I would say, whatever was specified by 3GPP, then implemented by the vendors and rolled out by the operators was pretty much the final product for the end customer. Here, especially when we go into the enterprise, we need to think differently. We need to think verticalization. It means that we have to adapt to the specifics of each industry, and this is something that we will need partners from outside the telecom industry, and we will have to work together with them. And the fail fast piece resonates here because it means we need to speed up the pace of innovation. Typical innovation cycles in telco are very long because we spend time aligning, standardizing, making sure that things are interoperable. We need a much faster pace of innovation, and then we need to be very, very quick to be able to roll things out. And for this, automation is key. Emmanuel mentioned it previously, but I really do believe that the idea of opening up the ecosystem, work with others, try things out, test them in the market, and scale them if they work, that's the kind of mindset and capability set that we require in telecom. And it's quite different from the new product introduction processes that we've had historically.
Thanks, Richard. Yeah, Emmanuel, as Richard said, we spoke about automation earlier. When we look at the new capabilities that telcos need to develop and roll out these solutions and services, it seems to come down to a lot of things we've been talking about recently: agility, speed, partnerships, co-creation, understanding customers. Are these the key issues that we need as we look to develop our new services based on 5G Core?
Yes, I fully agree. I'm sure that the services that we will have tomorrow on 5G are not the one that we can imagine today. So we need, and I think we have a good tool with slicing combined with the agility of the containerization to, let's say, to test, to fail, to define new services, to work with partners in order to set up this new 5G services that we will, let's say, which like our customers tomorrow. So definitely, yes, slicing combined with the agility of containerization is absolutely key in order to have a good 5G SA tomorrow.
Great, thank you. And Alex, we can't have this discussion without talking about security. What are some of the security challenges when it comes to 5G core that are different from what we've seen or needed in previous generations of cellular?
Yeah, as far as base capabilities that Richard, Mark, and Emmanuel have been talking about in rolling out 5G services, a baseline capability is security, and the security challenge is very different between 4G and 5G. I would say the bar is actually raised as we transition to 5G, and it's primarily because in 4G you had a fairly centralized architecture. You had a defined, a small number of vendors, and maybe it's a single vendor in some instances for the core network, for example. And then the interfaces between network functions were actually, proprietary, were actually defined, right? The connections, dedicated connections between network functions. As you move to a 5G services-based architecture network, now you're looking at a highly distributed network architecture. Some of the approaches that Mark and Emmanuel have talked about, starting with a small number of vendors, that's going to grow. And so, we fully expect that as 5G matures, there'll be more and more vendors introduced into the network. That poses a completely, different set of challenges. And then the interfaces between all these new and increasing number of network functions in form of microservices are now over a common service-based interface and no longer dedicated point-to-point interfaces. And so that poses, which is a great opportunity to roll out all these new great services and to be able to have the necessary infrastructure. But it poses a completely new set of challenges, which means that you have to be able to provide inter-function security, so security for data in flight between the network functions, as well as the ability to secure the authentication as well as secure private keys in the way security is implemented within the core and actually from core to edge for application authentication and then authentication that's required for encrypted data over TLS, for example, or over IPsec, depending on the network functions that you're talking about. So it's a very different set of security challenges, and not just perimeter security, which largely was sufficient in the 4G space that we've seen. Now in 5G, it's about authenticating new applications and encrypting data, because any single one network function that's exposed can actually expose your entire core network and maybe extending beyond that. So working with companies like HP and with cloud service providers, Intel has built-in security features in its CPUs from storage enclaves such as Intel Software Guard extensions or Intel SGX to crypto accelerators to accelerate traffic, IPsec traffic or TLS traffic, as well as trusted execution environment to ensure that the devices that are in the network, in the infrastructure, are devices that are supposed to be there. So yeah, it's a whole different set of capabilities for security that the industry is going to continue enhancing to ensure that as we roll out to 5G, that infrastructure piece, all extending to the edge. And ultimately in devices, it's also a set of different challenges and solutions that are going to have to be put in place.
Thank you very much for that, Alex. Richard, you wanted to comment?
Yeah, I think first of all, I think 5G is clearly raising the, Alex used the word raise the bar. I think it raises the bar in terms of technology, but also in terms of the significance of the network. We expect 5G to be far more pervasive in our lives than previous generations have been, and therefore the cost of failure on security is bigger than before. I think this is important to keep in mind. Then I think there's a piece of good news as well in all of this. When we talk about security, obviously we need to be able to detect a security threat, but then we also need to be able to act. And historically, the way that we've worked in telecoms, we've not been always that fast to deploy patches, even when we knew there was a security breach. And not to come back again and again, but I think the fact that we are looking to have a faster pace of development, of validation and rollout, and a higher degree of automation, this will help us also in this area, because it allows us to react more quickly and to be able to make sure that we deploy everywhere where we need to deploy the security patches. So I think there's some goods, there's some challenges as usual, but we will rise to the challenge.
Thanks, Richard. Before we end our discussion on 5G core, I do want to quickly look at this idea, this notion of a converged core. Emmanuel, do you think the idea of a core that supports both 4G and 5G could be a big help to operators moving forward?
I would say it's not a big help. I think it's mandatory to have it because, as I said before, if we want to have a simple deployment, it will be better to, at least in our case, this is the choice that we have made, to set up a new network for customer having 5G SA services, but they will not be always on the 5G converter. That's why we need this combo core. So it's not a help. It's for me, it's mandatory to have it. And this what we have decided for the RFP that we have just finished a few weeks ago, and I'm glad to have such a solution selected for Orange.
Well, that's good news, and thanks for telling us that. Mark, do you see a converged core as essential moving forward, and perhaps not even just 4G and 5G?
Yeah, I think for us, we see a converged core as a fixed and mobile thing, not just a 4G and 5G opportunity. For 4G and 5G, though, I also agree that it's basically mandatory to simplify your implementation, your IT integration, your single tool chain for software delivery. And it will help with the customer migrations. So as a customer migrates to a 5G service, and also, a lot of these new services that are used in the wide area network, as Emmanuel said, they'll be in 5G coverage sometimes, but they're going to fall back to 4G. And what happens to those services at that point? We have a lot of experience as well at dealing with mission critical services, and those are going to increase in the network over time. And we need to try and deliver a similar kind of experience or some kind of insurance in the 4G network. Beyond that, we see our network cloud on cloud native infrastructure as a converged platform for both fixed and mobile network functions. And we expect to see all of the benefits of scaling and efficiency from the larger platform that we have in fixed across our mobile networks of 4G and 5G, and see that as a significant opportunity.
Thanks, Mark. Richard, final thoughts on the need for a converged core?
I think that when we look at the standards, there have been clearly attempts to open up the networks and to make it easier to bring in a new vendor alongside an existing supplier by providing standards-based interoperability between 4G and 5G. And we do have customers that have chosen that path, and I think it's a good thing that that option exists. But we also see that in practice, in many cases, there's a desire to have this converged core. So the observations from Mark and Emmanuel are the ones that I see in most of the RFPs that we've responded to, is as a new vendor, and we are a challenger in this area. So outside of our installed base, typically the ask is always to replace the legacy piece, either in full or partially. So either an approach where existing 4G and previous generation subscribers stay on the existing core and you introduce a new core, as Emmanuel was explaining, where you run 4G and 5G on a single core, or for those customers that are already on 5G, or a complete replacement where you just swap the existing vendor. So in practice, while the standards have made this attempt, I think in practice what we're seeing is most operators are following a strategy of converged core, and we're very happy to supply that to those customers.
Okay, thank you everybody. We have to leave our discussion here for now, at least. Thanks for sharing all your views and opinions. Well, that brings our strategy outlook on 5G Core to an end. But my colleague Ray Lemaitre will be back tomorrow with an in-depth look at 5G RAN. And a reminder that you can view an extensive series of programs as part of our Spotlight on 5G week, from interviews and roundtables to live Q&As and special features. We'll be showcasing new content throughout the day, Monday through to Thursday. Today you can watch the first 3 episodes of our Top 10 Moments in Mobile, where we take a look back at our best video content from 20 years of covering 3GSM and MWC. And tune in at noon UK time for The Slice, our daily news and analysis programme. Then Ray and I will be back at 5 PM UK time for the live after show, along with plenty of guests and 1 or 2 surprises. We'll also be answering your questions live on air, so please send them in now and we'll see you later. Goodbye for now.